Hi everyone, welcome back to my channel Learn at Cloud Analytics. So as part of the Power BI Zero to Hero series which we started since yesterday, so I would be walking you through the topics that we would be covering in today's session and quickly give you a glimpse about the GitHub repository that I've created for this series and make you comfortable in accessing to the content and also to the details which I would be sharing in the next few minutes. So this is my repository which I've created exclusively for this playlist series where you would find day-wise details about for example, in today's session we are going to touch base about the introduction to Power BI. Now, for every video that I'm going to release from here on, I would be creating a separate folder and like this, and you would be finding all the required artifacts in terms of the documentation, or if there are any workbooks that I might use during the course, I would also be adding it within my repository in that particular respective folders, so that you can at any point in time can be able to refer back, revise the topic and be able to implement it effectively. So that's the intent of it. But since I would be doing on a daily basis, so the documentation or the corresponding artifacts would only be uploaded on that particular day itself, like at the time of publishing this video online, or probably a couple of minutes later once this video is available online. I would make sure that the related artifacts are available within that corresponding folders here. So this is about how you can access to the details of content while we handle the different uh, conversations throughout this particular series. And if you're someone who's visiting my channel for the first time, let me quickly introduce myself. I'm Sailaja and I have over 12 plus years of experience in data and analytics stream, and I've been creating content around Power BI and other analytics as well. And you can find all these related videos on my channel, which is Learn at Cloud Analytics. So predominantly I've been focusing on providing some real-time use cases, how you can handle if required in your project, with some tips and tricks and also with some solutions in most of my content. But this particular series which we started since yesterday is mainly focused to inspire and support a new developer who's trying to make their career in Power BI, or someone who's already working on a different technology but they are trying to make a shift, a career shift into Power BI, then this particular series would help them to go through that. So in the first day zero, which I've not listed here, but I've went through all the course content and the course structure, how we are going to handle it on a daily basis. Now let's get started on the first day of content, which is the introduction to Power BI. So this particular class alone would be little theoretical because the basics have to be understood before we even dive into the concepts of this particular technology. So I hope this basic fundamentals is not so boring for each one of you, but rather build some foundations to understand the later concepts that we will go in detail in the next modules. So with that said, let me go back to my repository for day one, and this is my documentation that I've created for you to go and access and be able to revise. And let me get started on the topic today. So the first topic that I would like to touch base upon is the data warehouse architecture. Now you might have a question like, why do we need to understand the data warehousing architecture when we are focusing on Power BI series, right? Yes, it is totally right, but on the other side we also need to understand where exactly does this Power BI tool fit into the entire workflow structure in real time, right? Because when you're given a project, you also need to understand from where do you get the data from, and who is trying to provide you that curated data, and how are you trying to analyze this data, which is needed for the business to make some informative decisions on. right? So because of that, I have started off the topics from the data warehouse architecture, and let me explain you here. So I just took a very basic diagram that is found on the internet, uh, which I felt personally is relatively simple to understand for someone like a new fresher, or maybe someone who's quite new to this particular data warehouse architecture. So with that said, so you can see the diagram of the entire architecture in this image, but let us consider a real-time situation, how we can, relate that with respect to this architecture diagram. Alright, so for this particular understanding, I have taken the banking scenario where I have took an example of any bank, let it be SBI or HDFC or Citibank or any other, right? But for this particular scenario, I'm just focusing on one particular bank, which is SBI Bank. Now, assuming that SBI Bank is located across the globe with several branches in different locations, but for ease of understanding, let's pick only three different locations. So here for our understanding, I have considered US, UK and India. So we've got uh, the SBI Bank located in these three different locations like India, US and UK, and whatever the transactions that are happening in those respective banks, the top management would like to analyze how the business is performing across the globe. Now, this sort of an analysis is quite difficult without use of any technology or without the use of IT incorporated into the system. So let me explain in brief, like why is it quite important here, because so in this particular situation where the top management of SBI Bank is interested to know or understand how the business is doing or performing across the globe, what are the prerequisites that we would have to consider here? So the prerequisites for me to analyze or assess how my business is doing is that across all these three different locations, I would have to gather the information needed for me to analyze this data, right? So what is that information that I would require? Like I might need to look at the number of customers spread on that particular locations and how many transactions are being conducted on a daily basis and also on a monthly basis or in a specific time period as well, and how much revenue is that bringing up to my business, right? So these are like the important KPIs or the important parameters with which I would be able to make an effective decision of analyzing if my business is doing good or if it's not performing at the expected rate in a specific location or two, right? So let me recap. So what are my parameters that I'm interested to consider here? So the first one is how many transactions or how many customers are located in each bank location, and then um, how many transactions are performed on daily and monthly basis. It could be any time period as well, but to make it simple, I'm just taking it for daily and monthly basis. And which location is bringing more revenue than compared to other. Okay, so these are my these are the three important questions which the top management of SBI Bank is interested to answer, or they wanted to get answers to these particular questions in general. Now, assuming that we have SBI Bank, right? So which is located in the US UK and India. Now let's say that in the US location, and again within US premises, we do have multiple or several branches located in different regions also, right? In different cities and different states and everything, everywhere else. But concluding together, like combining everything together, assume that in US we have around 1,000 branches. Okay, and in those 1,000 branches, let's assume that there are like oops, okay, 1 second. There are like 1 crore customers in total. So spread across all those 1,000 branches, assume that there are in total 1 crore customers. Now, to understand how how many transactions are being performed on a daily and monthly basis, now let's calculate that particular scenario as well. So assume that for one customer, if there are like, if one customer is performing at least one transaction per day, okay, now for 1 crore customer, how many transactions could happen? So it would be again 1 crore transactions per day, right? So if we say that there are 1,000 branches in US with total of 1 crore customers, and assuming that if every customer performs one transaction per day on an average, then with respect to the total count of customers, which is 1 crore customers, there would be 1 crore transactions happening on a daily basis. So this is what we have been able to calculate. Now for these 1 crore transactions, if I have to calculate for 30 days, then it would be, for 30 days, there would be a total of 30 crore transactions per month, right? So for 30 days, there would be the total transactions of 30 crore per month, isn't it? So now, in the similar fashion, for the rest of the locations also, we would have, assuming the total count of branches and the customers are the same, so we would again be having 30 crore transactions per month in UK, and similarly in India we would again have 30 crore transactions per month in India as well. So which means that collectively across a month, for all these different locations in US, UK and India, we would have a total transactions of 30 plus 30 plus 30, which is nothing but 90 transactions or 90 crore transactions per month, right? 90 crore transactions per month, and this is the total across all locations. Okay, so now how can the top management be able to assess in which location do they have the highest transactions? But in this situation, for in this particular example, though I've considered it uniquely across all the locations, but in general it wouldn't be the same across all the different locations, right? So there would be different transaction count happening at different locations, so the count is never the same. And now if the top management is trying to analyze or understand in which particular location do they have the highest transactions for that particular month or a different timeline, how will they be able to assess this information or access this particular information? So it's quite difficult, right? Because how do they need to get, like, okay, let's say consider all the possible options here. So in order to find these transactions across all the branches, what should they do? They should hire some employees at each individual branches who can be able to collect the daily transactions at that particular individual branch and another person who can then be able to combine all these daily transactions data into one single format or into one single file, so that they would be able to filter and analyze further information as required. And this is quite difficult. It's not so simple to combine data coming in from multiple branches and combine and assess and analyze on top of that, because which is a huge volume of data. For this particular scenario, we just took like around 1 crore transactions per day, but assuming if it's a real time situation, there could be much more uh, many transactions than this count as well, right? So in that problem, in that particular situation, IT is coming into picture. So they would then approach the IT, which is nothing but the information technology. So they would try to adopt this new technology within their banking system to help them find, or to help them to ease out the calculations of all these assessments that is needed for the management. So that's where exactly comes into this data warehouse architecture. Now, by implementing a data warehouse architecture within an organization, what benefits do they get? Or let's first understand this architecture design here. So, in this diagram, the first boxes that you see in the blue color, right? So, these are nothing but different data sources. So, in general, the data is flowing from multiple sources. So, consider the banking system. How do you make a transaction? So the possibilities of performing a transaction within your account could be an online transaction, right? Which is nothing but the web. The second way of performing a transaction could be you can approach your nearest bank in person and you can perform the corresponding transaction that you are interested in. And so that's the second way of doing things. The third approach is that you can also approach to a nearest ATM and you can perform either a withdrawal or a deposit, right? You are also allowed to perform a deposit at certain ATM centers as well. So you are also performing the transaction at a nearby ATM. So these are like the three different modes of performing transactions on with respect to your account. Now these three different modes of transactions are then supposed to be collected together, because you're the same customer who's trying to perform transactions but at three different modes of interface. Now all this data has to be combined or brought into a placeholder where you will be able to combine all this data together, and if needed you might need to do some transformation in order to make sure that all the data is you know uh, standard structure or in a uniform format, which would then be helpful for your further analysis. And that is exactly what is your ETL layer would does. So ETL stands for extraction, transformation and loading. Now what are you extracting here? You are extracting the data that is residing in different data sources. You are pulling the data from all those different data sources. And what are you then trying to do? After you extract from all the different data sources, you're trying to transform the data. Why do you need to perform the transformation? So in this given scenario of banking system, let's say that I pulled in the data coming in from UK, US and India. Now all these three different locations transactions, how are they being stored individually? They are stored in their local currency, right? In US the transactions might be stored in the dollar currency, while in UK it might be in pounds or euros, and similarly in India it would be in rupee. So we need to make sure that all these three different data that we have brought into the ETL layer are transformed into a uniform currency structure. It could be in dollar, it could be in pounds, or it could be in Indian rupee as well. However, whatever the currency format that we have picked up based on the business requirement, If at all, if we can convert them into the same currency format, only then I would be able to understand if that particular location is performing or bringing more revenue to the business, or if they are doing less business over that particular region, right? And that is the transformation. So transformation is nothing but performing some business transformation to make sure that it is easily understood, or it is easier for us to analyze the business going forward. And once we make the right transformation on that particular combined data set, then comes the loading phase. So all the transformation and extraction that we have on this layer is a temporary placeholder, but then once the transformation is completed, we would have to then load that transformed information into a placeholder, a bigger container, where it can hold for a longer duration, which would then be able to accessed by the business analysts or the BI developers in the organization to make some informative decisions on top of that, right? So that is where we will load that particular transform data, which is nothing but the information, into this big container. Now if you compare the size of these individual data sources at the beginning and this container at this layer, both are comparatively different, because the initial ones are a smaller container because they are only holding the daily transactions of that particular region, while this particular data warehouse container is holding all those transformed information coming in from multiple locations, and that is where the volume increases and it requires a bigger container. So that's why the container size is comparatively bigger than with respect to these individual ones. And these containers are nothing but the OLTP. OLTP is nothing but online transactional processing system, and this is nothing but the OLAP. OLAP is nothing but online analytical processing system. And we will see a little bit deeper in understanding both the terminologies a little bit further. But for this current architecture diagram, let's see what happens next. Now we have all the information stored, which has the right formatted transformation applied on top of your aggregated data already, and this can then be used for further reporting and analysis within the organization. Now on top of this comes the BI layer. So here comes the BI layer, like you and me, who are trying to connect to this data warehouse, analyze the data based on the business conditions and or business requirement, and be able to present them in a visual representation by using some charts and graphs within that particular technology. And that is the overview about the end-to-end process flow of a data warehouse architecture. So now you understood that this is the BI layer, and this is exactly where we are falling into place. And from here to here is the ETL phase, which is usually handled by a separate team in real time called the ETL developers, who are predominantly focused on bringing the data from the real time data sources and trying to perform some business transformations as needed, and also they would try to add some business logics which is needed for further BI reporting as needed from the business management, and then they would try to load the data into a data warehouse. So all these process is being handled by the ETL team. Okay, and we are just trying to connect to that particular transformed information to that particular data warehouse and build some analytics on top of that. Alright, so this is all about the data warehouse architecture. Now what are the key components of a data warehouse? So we already understood that we have the key components, like the first one is the OLTP, and then we have the ETL, and then we also have the data warehouse or the OLAP, and then finally we have the BI layer. So these are the key components of a data warehouse architecture. There could be several other representation of a data warehouse architecture as well, which is a little complex to understand, but at the very basics of you and me to understand the basic foundations of a data warehouse architecture, I think this simple architecture is pretty much comfortable and enough for us to grab in details. Now let's try to understand what is an OLTP. So OLTP is nothing but it holds the day-to-day transactions. Now what do you mean by a day-to-day transactions? Now in the same example, okay, let's say that I would like to perform some withdrawal in my with my account. So what do? I just approach to my nearby ATM, and then I try to enter some data. What data do I usually enter? I insert my card, right? It reads my card data and identifies that this is a valid account in their system, and I can be able to perform further transactions. And then it will ask me to provide a PIN number, which would then be able to access to my account to perform the transactions, right? So using my PIN, I would be allowed to withdraw or do any sort of a transaction that I am interested in. Now in this case, I approached my ATM and then I inserted my card and then I entered my PIN code. So what details do I provide? PIN code is just nothing but a random number, right? And that doesn't need to mention anything about that particular PIN number. Like, okay, I need not write explicitly on top of that, okay, this is my PIN code or this is my PIN number, right? So it understands. So the system understands. So anything which is understandable by the system is nothing but data. So data could be anything. It can be in any format, it could be in any structure, but if that is understood by the system, then that is called as a data. But again, it's not understood by humans, okay, unless and until we know that, okay, if I randomly write some number like 1234, you wouldn't understand what is that 1234 referring to, right? On top of that, I might need to add some additional data like, okay, this 1234 is a value corresponding to the column of maybe pin code. Then I understand, okay, this is my pin code number, right? So this is my data stored in the OLTP. Now every day I might perform some transactions and that transaction is immediately reflected and displayed on my account with that particular transaction ID. So for storing the day-to-day daily transactional data or information is nothing but an OLTP. It's like a small relational database where it holds the day-to-day transactional information. And then next we have the second component, which is the ETL. So like I did explain already, so it is the process of extracting data from different data sources and transforming that particular data into the required format. And once that is transformed into the right structure as needed, then finally we would be loading this transformed information to a data warehouse for a permanent storage, so that at any point in time we can be able to connect to that data warehouse and perform some business analysis. And then we have the OLAP. So OLAP is, again, it's the permanent location like I just mentioned, that holds the transformed information which is used for the reporting and analysis, and this also holds all the historical information. So this is one comparison that I can say, where OLTP holds the day-to-day transactions while OLAP holds historical information as well. And then BI. So BI is nothing but it is a process of incorporating intelligence to the information stored in the data warehouse by performing analysis and reporting. So what is that intelligence? So we need to tell the system how it should, like all the conditions or all the, okay, let's keep it simple. So we've got our data. So I've connected to a data warehouse. I have all my tables and the data within my respective tables. But in order to analyze the business of a company, I might need to write some additional conditions or logics, and then I might need to present it in a way that I can be able to get all those questions being answered appropriately. And that is where I'm parsing, I am incorporating some intelligence from me to the information stored in the data warehouse by performing the required analysis and reporting. So that is the business intelligence. Now with that said, let's quickly look at the comparison of both OLTP and OLAP. So I've given few features based on which we would be able to understand this a bit more in detail. So the first feature is the source of data. Now for OLTP, what would be the source of data? So like I said, OLTPs are nothing but the user interface databases. So in the given example, when I approach an ATM, right, the user, myself, being a customer of my account or of that particular bank, I'm able to interact with that particular database. Like I'm able to perform all my required transactions and able to do the required things as needed. So any user interface is considered as a OLTP. While the OLAP, for OLAP, what is the source of data? So OLAP has the data coming in from the OLTPs, right? So after combining the data pulled from my OLTPs, I get this information stored in my data warehouse. Therefore, my input for this data warehouse is coming in from my source of OLTPs. The next comparison feature is the purpose. When do we use OLTP and OLAP? So OLTPs are predominantly used to run the business, while OLAP is used to analyze the business. So how exactly does this explain? So OLTPs, so if I don't go to a bank and perform any sort of a transaction, then the business wouldn't run, right? Like me, there are like crores of customers associated to that bank. Now if no one does any sort of a transaction, then there is no business for that particular bank, right? So in order to make sure that the business is running, we would have to make some transactions. So OLTPs are used to run the business, while OLAP, after all the transactions are being performed, and if I would like to go back and check how my business is performing for the last 1 year or for the last 6 months or for the last 1 quarter, I would be able to analyze the business, right, by connecting to my data warehouse data. So that is the purpose of using OLTP and OLAP systems. The third feature is volume of data. So the volume of data for OLTP systems have comparatively less volume of data. So they have very less amount of data. Why? Because OLTPs are mainly used for daily transactions, right? Now for daily transactions there wouldn't be more when compared to an OLAP system, because in OLAP you're actually combining all the daily transactions coming in from multiple locations together. So therefore the volume of data is huge in OLAP while it is very less in OLTP system. Now what is the processing speed? So processing speed is directly proportional to the volume of data. So since in OLTP it has very less volume of data, the processing speed is nothing but how quick is that system performing, right? It is quite fast in OLTP while it is little bit slow compared to OLTP, because it has to read through the whole data that it has within that data warehouse and present us with the required output. Therefore the volume is high and therefore the processing speed is also little slower. And then comes the operation. So what sort of an operations do we usually perform on an OLTP system and OLAP system? So in an OLTP system we usually perform insert, update and delete operations. Okay, let me give you with the same example of an ATM transaction. So when I go to an ATM center, uh, what could happen? I might try to deposit some amount, which is nothing but an insert operation, right? How is it an insert operation? Because when I do a deposit at on my account, then the same transaction is reflected within my account as a line statement entered, saying like, okay, on this particular day and time I have deposited so and so amount. So that is nothing but an insert to the operation. And the other one is update. Now as soon as I perform any sort of a transaction, whether it's a withdrawal or whether it's a deposit, my accounts gets updated every time, saying like, until my prior operation, my total balance in my account, let's say it is 10,000 INR. Now with this particular transaction that I performed, it might have went up to maybe 12,000, or maybe it went down by 8,000 as well if I performed a deposit or a withdrawal corresponding to it. Now delete operation is nothing but kind of a withdrawal. So if I just draw some amount from my account, then that amount gets removed from my account, right? So that is relatively compared to a delete operation. Similarly, on OLAP, what do we perform here? We are not performing any daily transactions, and more or less this OLAP system's data is not accessible to a end customer. So I can't access to the OLAP system. Why? Because it has all the information coming in from multiple OLTPs for different customers and everything in one box. So I wouldn't have access to the OLAP information, but rather only the business officials would have that corresponding access, and they usually perform a select operation. Select operation is used to analyze the business operations, right? And the next feature that we have is the database size. What would be the size of the OLTP and OLAP system? Since OLTPs are very small databases like a relational database, it can hold up to 500 gigabytes of data. While OLAP system, since it's meant for a data warehouse, this can hold in petabytes and terabytes of data. And the storage, the OLTPs mainly store the transactions for temporary basis. So as soon as you perform a daily transaction, it gets removed from that system because it doesn't need to hold a longer period transactional data in that OLTP system, right? It doesn't require. So for that particular transaction, it just stores the information temporarily, and once your transaction is completed, it will just remove it out of its queue. And while the OLAP system, it holds all the transactional data, like it stores all the information that is coming in from the OLTPs for a permanent use. So once the information is loaded to a data warehouse or an OLAP system, the information is stored for permanent, unless there is some need for us to make some deletions or removal of anything. Other than that, very rare case scenarios, the information is once stored in OLAP is stored for permanent use. So these are few feature comparisons with respect to an OLTP and an OLAP system. So I hope this is understood and clarified for most of you. But in case if something is still not clear, please do leave a comment in my comment box so that I can be able to explain that in detail, either in a different session, or maybe I'll take it up as a Q&A session at the end of the week. Alright, so with that said, with all the basics laid out on understanding where exactly do we play into picture with respect to the whole data warehouse architecture stream, now let's go and understand what is Power BI and the basics of Power BI as well. So Power BI is a business analytics tool developed by Microsoft. It is a cloud-based tool where it's mainly used to visualize and analyze the data for making informative decisions for business requirement. And what are the key features of Power BI? So I've listed few key features like the data connectivity. Since Power BI is a product from Microsoft, right, it has given a ease of connections to all its Microsoft data sources. Along with that, it has also provided access and connectivity to other data sources. So it has a wide range of data source connections option, and that includes all the databases, all the cloud services, all the flat files, and also the web sources, APIs, and everything. And then we have the data preparation. So unlike any other BI tools, for cleansing the data or putting that in the right formatted structure, we need not rely on a ETL product separately, but rather Power BI has an inbuilt ETL tool called Power Query Editor, through which we are able to perform all the data cleansing and data transformations that is needed for our data to analyze. And then we have the data modeling. So even the modeling of the tables can be done within Power BI itself. So Power BI on a nutshell is a suite of tools, different tools and capabilities which are integrated into the same technology itself. So by using one product from Microsoft Power BI, we are able to connect to different data sources, we are able to make all the different transformations, and we are also able to perform the data modeling on top of the connected tables. And then finally, once the tables and everything are arranged in the right format, we are able to perform the visualization which is needed for the business to make some informative decisions. And along with that, it also has some key features like the advanced analytics. So you can also incorporate some advanced analytics features like forecasting, clustering, or performing some sentiment analysis, right? So you can perform some wide variety of advanced analytics with the existing features itself. And we also have the capability of performing the natural language processing. So this is another key feature where you can just chart questions to Power BI in order to get the right answers displayed in a visual insights. So even if you're unsure of how you can use that particular data and bring it in a visual format, you can just post some questions asking Power BI, okay, what are my total sales in east region, and then it will try to bring up the data together in a visual representation, and you are good to go and use that directly. So that is also another integrated feature within Power BI. And sharing and collaboration. So once you build any report or a dashboard, you also need to have the flexibility of how easily and seamlessly are you able to share this particular report to the rest of your business, or to your team, or others who would need to collaborate and provide a informed decision around that particular visualization. And we also have another key important feature, which is the security and governance. uh, for any BI tool or for any technology, with that said, security and governance plays a vital role, because we don't want to make sure our data is accessible to everyone, or even there is some unauthorized person who can read the data, right? That would lead to a lot of issues within the organization. So it's quite important that whatever data that we are publishing it openly on the web, we need to make sure that it has all the robust security and governance added to that particular technology. And as part of that, there are different features included, like the row level security or encryption of data at rest and transit, and providing all the compliance and regulatory requirements that an organization is needed. And we also have an ability to access all your published reports using your mobile. So we have Power BI mobile apps which can be installed through your Play Store, right, or iOS, and you can just go and access to your reports anywhere, anytime, anytime. And then we also have this integration with Microsoft ecosystem. So like I already did mention, since it's from the Microsoft vendor, you have that ease of connecting to all the Microsoft suite of products and services seamlessly. It is integrated so efficiently and easily that you can just bring in data from any of the other ecosystem of Microsoft family. So these are some key features of Power BI, and with that said, let's go to the next topic, which is Power BI ecosystem. So in Power BI ecosystem, we do have several products that have been launched, and we often get confused from one another, thinking about maybe this is this particular product, or maybe this is where we can use this particular product, and how and when can we use this particular product, or we often exchange the terminologies as well. And that is why I would like to emphasize on making sure that we understand the products individually and when they are used for which particular requirement. So the first component that we have here is the Power BI desktop, or the first product that we have within the Power BI umbrella is Power BI desktop. So Power BI desktop is a local application, or a local or a standalone application where the complete development would happen. If I'm a Power BI developer, I would definitely require having this Power BI desktop application installed on my desktop and be able to do all the necessary developments as needed. So it is the core component for all the Power BI developers, and this is where we are able to connect to all the different data sources and build some reports and visualizations. So Power BI desktop is a key product from Power BI ecosystem. Power BI desktop is a free application, so there is no cost associated to download and use this product. So you can just go ahead and download and start exploring this product from here onwards, because we will be exploring and using this major product within the next series of conversations. The next product that we have is the Power BI service. So Power BI service is an online or a cloud application which is available as a software as a service product. So when we say software as a service, let me tell you as a quick example. So you don't need to, you are not responsible in configuring the product, or you're not responsible for any product updates or upgrades or anything as such. So all you require is access to the Power BI service on the web. You go and access by authenticating yourself. If you are a valid user, then you would be allowed to access to Power BI service interface directly. So we will see as we go along the series how you can access, or how you can get an account being created for free of cost. So I would also be providing all the details to you. But like I said, Power BI service is a cloud application which is available as a software as a service product. So this is the business intelligence service which is mainly designed to help the users to visualize and analyze the data in a centralized environment, which means that once you develop reports using Power BI desktop, how are you going to collaborate or share your reports to rest of your business stakeholders? So you need to have a forum where you can make it accessible to everyone, right? And that's exactly the importance of using Power BI service. So you are allowed to publish your reports from Power BI desktop to Power BI service, and with the access that is granted to those reports within the organization, the users are able to consume the data from those particular visuals and charts. But this is maintained and managed by Microsoft itself, because it's a SaaS product. You are not responsible to install the product nor perform any maintenance or product upgrades as and when there is a new release being launched. So Microsoft is taking care of all these things together, and that's the key element of a SaaS product. And this is a licensed application, unlike Power BI desktop, which is a free application. But Power BI service is a licensed application, and that comes in with two modes. So when I say it's a license, it comes with two licenses. One is the Power BI Pro license and the other one is the premium license. So Power BI Pro license is used for a smaller organization. So let's say it's a startup company and there are like hardly 3 to 5 users. So for those 3 to 5 developers, you don't need to procure a heavily invested premium license, but rather you can just go and get pro license, which is per user charged on a monthly basis, which is around $9.99 dollars per month for a user. So for that particular small requirement, like for 5 to 10 developers, you can just go and get the license by paying hardly $10 per month for every user, and that cost would relatively be lesser than the premium license. Now when do we go with the premium license? Premium license is used mainly by a wider organization when it's an enterprise based, or many there are hundreds of users within the organization who are trying to use this product and able to consume these features with Power BI service and Power BI desktop. They require a premium license. So this premium license cost would be somewhere around $5,000 or something. So it depends on. So this premium license is separate and pro license is different, because pro license is calculated per user while premium license is also calculated based on users, but it comes with some bulk. Like let's say they would evaluate the licensing based on like 200 users or something, and based on which all of the users within an organization can just avail this license. The other one is the Power BI report server. So Power BI report server is so let's say that Power BI online or Power BI service is a cloud SaaS product, right, which is an online product. Now if there are few requirements within the organization where you see that this particular data cannot be uploaded onto the cloud vendor like an external or a public cloud, so that's when you go with the Power BI report server, which is usually a on-premises installation, and where you are responsible in installing and configuring of this particular product, and you are also responsible for the maintenance of that particular product. And when do we use that? If your application or if your business data that is holding is quite confidential and that cannot reside on a Power BI service, that's when you try to create a Power BI report server within the organization premises, and then you try to publish your reports to this Power BI report server. So both Power BI service and Power BI report server are more or less the same. Only difference is that Power BI service has much more features than compared to report server, and also Power BI service is a cloud SaaS product, while Power BI report server is a on-premises version to it. Okay, and this comes for free of cost when you procure a premium license for the organization. So this license is given for free of cost, so you can just use it for a smaller requirement within the organization. And then we have the Power BI mobile. So Power BI mobile is used for by the end users or by the stakeholders who try to access to the reports that are published on Power BI service using their mobile. So for within the mobile, if they would like to access the reports at any point in time, they can just install this Power BI mobile product, which would help them to easily navigate through these different reports that they have access to, and analyze the data as needed. And then we have this Power BI embedded, and this is an Azure service that helps us to embed or integrate interactive reports and dashboards into the web and mobile applications without doing it manually from scratch. Okay, so if you're trying to integrate your reports built in Power BI desktop into a custom application, then you can use this product called Power BI embedded. So this is the overview about the entire Power BI ecosystem. And in case if there is still further questions to understanding of any of these products, please do leave a message in the drop down, and I would be happy to help you to clarify those questions. And if you like this content so far, and if it's interesting, or if you have any further feedback or comment, please leave a comment in the comment box. And also leave a message saying if you have already tried to explore any of these products, or if your organization is already using one of them. Okay, now let's go to the last concept or the last topic for today's session, which is the Power BI history. I know that it's not needed or it's not helpful for us to go through the history of when it started and what is its timeline of how it incorporated and who has started, but it's always good to know all these history of the evolution of Power BI, because since we are trying to use and learn this product, a new product, right, it's always helpful for us to see, look back and understand how did Power BI evolve over the years and how much time did it actually take to arrive at this level of product features, right? So that's why I felt probably it would be useful. You don't need to remember all these dates and timelines, but it's good to learn about it as well, right? So the first one that I would like to talk about in this entire journey is how it all started for Power BI, right? So there was a project, or there was a code, or there was an initiative rather, I would say, from Microsoft with a code name called Project Gemini. And this was introduced by Amir Nets, who is a distinguished engineer at Microsoft, and along with his team, they have aimed at addressing the growing need for the self-service business intelligence tools within organizations. So that's when it all started off. So this what do you say, like the evolution of Power BI has actually started in 2008 and 10 from Microsoft's internal initiative called Project Gemini. So they wanted to actually enhance the existing Excel's capabilities of data analysis and reporting, and therefore with the help of Amir Nets from Microsoft and along with his team together, they put forward this particular project and they've started exploring it. Now what happened later on is in 2010, as part of Project Gemini, they've introduced Power Pivot. That's when this Power Pivot has come into place. So in 2010, as part of this ongoing Project Gemini, Microsoft introduced Power Pivot, which is nothing but an add-in for Microsoft Excel that allowed users to create the data models and perform some in-memory analytics on large data sets, and also help them to create some interactive reports and dashboards. So Power Pivot enable the users to analyze large volumes of data within Excel, leveraging the power of in-memory processing. Now what happened later is in 2012 they have so they have seen the success of Power Pivot in 2010 with the launch of Power Pivot in 2010. With that success, what they have done is they try to add some additional components as part of this ongoing project Gemini. And what component do they now add in? In 2012, they brought this new component called Power Query. Okay, so this Power Query and Power View, it helped them to provide advanced data transformation and integration capabilities, allowing the users to import data from different data sources and perform some cleansing and shaping of the data as required. So that is the main requirement of Power Query, right? And while the Power View is mainly used for creating some interactive visualizations using some charts, graphs, and all of them. And this has been integrated directly within Excel. Okay, so in 2008 and 10, they've started an internal initiative called Project Gemini, and then in 2010, they brought in a new component called, or a new add-in in Excel called Power Pivot, which helped them to perform some data modeling within the data set in Excel. And with that particular success that they've seen in with the launch of Power Pivot in 2012, they've brought in some additional components or additional add-ins to Excel along with Power Pivot, Power Query, and Power View. So Power Query is used for all the data transformations, and Power View is used for creating visualizations using that particular data sets. So these are all added to the existing Excel itself as part of the Project Gemini. Now what happened later? Now in 2013, that was when Microsoft unveiled Power BI for Office 365. So that was the first time when they actually released Power BI for Office 365, which had expanded the capabilities of Power BI suite beyond Excel. So it included the cloud-based service for sharing and collaborating on reports and dashboards, as well as mobile apps for accessing BI content on the mobile devices. So they envision to build a modern cloud-based business intelligence platform with the help of Power BI for Office 365 product, and that is when it all started off. And what happened later on is, for the first time in 2015 in July, Microsoft made Power BI generally available as a standalone product separate from the Office 365 subscription. Okay, so initially in 2013 we had Power BI for Office 365, where it was in the Power BI service, to be honest, right? So we have the other product, right? Power BI service. So it was initially launched as part of Power BI with Office 365, but in 2015, that's when they have released Power BI Desktop as a standalone application. Which can be downloaded on our desktop, and where we can try to incorporate all these features as needed. And along with that, even Power BI mobile apps has been launched together with Power BI desktop, which would help users to easily connect to the respective reports and dashboards that are built in desktop and be able to consume the data from those reports. And then what happened? So in 2017, that's when we had Power BI Premium and Power BI Embedded have been launched. So in 2017 May, Microsoft introduced Power BI Premium, which is a capacity based licensing option that provided dedicated resources for running Power BI workloads. So this Power BI Premium offered enhanced performance and for handling larger data capacities and advanced features. And they also have launched Power BI Embedded to allow the developers to integrate these reports and dashboards into their own custom applications and websites and portals. So, and from there on, there had been a tremendous continued innovation and growth that we are all are seeing from all these years together. I was not able to put across the rest of the timeline into the history, but however, we know that from 2017 onwards, what were the different timelines did we actually see in with respect to the different features and capabilities that have been brought with the innovation and growth throughout this entire timeline. So today we already see that we have the fabric being launched, right? So there has been a tremendous growth and innovation, and a lot of changes are happening on a timely basis. So with that said, let's conclude the session here. So I know that this particular day one is a little bit of theoretical, but I would definitely promise you that from the next session onwards, it would be more interactive and more practical scenarios. But since I would definitely have to touch base on the introduction and the foundations and basics of Power BI, I had to go through all of these content. But I hope this content was useful and informative, and it was easier for you to grasp the things which I intended to convey. But in case if you're unable to follow, or if you think that my pace of explanation is too fast or too slow, or somewhere I have missed few things, please do let me know within the comment section, so that I can be able to make some changes in the next sessions as well. So all this documentation is accessible to all of you, and like I said, after every class I would be uploading the necessary artifacts in that corresponding folder, so that you are able to access and use it as needed. And what is the assignment for today? So I would advise strongly to please go ahead and download Power BI desktop on your workspaces, like on your laptop. So this is the website. You can just go and hit Power BI desktop, download Power BI desktop, and you would be gone to this particular page, and you can then be able to look through the products, go to the download section and download that. So it would go to the Microsoft Store, but then you would be able to download it. So you have all the products listed here. If some of you who still doesn't have this Power BI desktop installed, I would strongly advise and request you to please do that immediately, because from tomorrow's class onwards we will be doing a lot of practical scenarios, and it would be helpful for you if you can just do that after you listen the concept and understand it immediately, so that you remember the concepts for a longer period. Okay, so with that I would conclude, and thank you again for all your support, and please do watch this video series. As I said, we would be going in detail, and I would be taking a lot of time as well. Though I mentioned randomly as day 2, 3 and 4, I might even extend it for a longer days as well. So I hope this video is helpful, and thank you again. Until the next video, bye.